Um, so it says here, Diego drank X ounces of juice. Lynn drank 1/4 less than that. Okay. It's good sometimes to pick a number. Okay. I don't know if you've been to restaurants, sometimes they actually tell you, like on the menu, they'll say, you can get 8 ounces of juice, or, it's 6 ounces of juice or something. They used to do that. I don't know if they do that anymore. Sometimes it's small, medium, large. Now, if Lynn is drinking 1/4, we should pick a number that's divisible by 4. Okay, and we'll get to the graphs in a moment, but can you think of some numbers that are divisible by 4?
Uh, like 8.
8. So like 8's good, 4 is good, 8 is good, 12 is good, right? And so on. So when you're looking at the graphs, you kind of want to think through that. You're like, all right, so let's just say Diego, and I'll just pick 4 as an example. He drank 4 ounces of juice. Lynn is 1/4 less. Now this is a little bit complicated because it's not that Lynn is drinking 1/4 of what Diego, it's 1/4 less. So it's almost like you had to figure out, well, what is 1/4 of this? And then subtract it from the 4 there. So what would be 1/4 of 4? Let's try that. Were you working on fraction multiplication over the fiscal week?
Uh, yeah, because a lot
Okay.
of people in my class forgot.
Right. So you
Um,
multiply the tops, you multiply the bottoms.
would it just be 1?
It would be. It's 4/4, which is 1, but that's how much less. So if Diego drank 4, how much did Lynn drink?
4? Wait.
Diego drank 4. Lynn is 1/4 less. We know that 1/4 is 1. So it's 1 less than 4.
3.
3. So now we're just looking for a picture that illustrates that. Now let's just say you went with a different set of numbers. Let's say you're like, okay, Diego drank 8 ounces of juice. Okay. Lynn is 1/4 less. We need to figure out what is 1/4 of 8. 1/4 of 8. You're multiplying the tops, multiplying the bottoms. 1 times 8 is 8. 4 times 1 is 4. That becomes 2. Lynn drank 2 ounces less than Diego. 2 ounces less is 6.
6.
You see that these are in the same ratio, like 4/3 is the same as 8/6.
Yeah.
Okay, so you're looking for a picture that illustrates this ratio. I don't know if you have those pages in front of you, but
I
which
do,
of
yeah.
the which of those 3 would it be?
C.
Okay, so C does not represent how much. Well, let's look at C. So if Diego drank 4 ounces, then Lynn drank 1 ounce. Is that what you have here?
Oh, wait. Yeah, never mind.
Okay, so it's not that one.
B.
It's B. Yeah. B, because you can say that X, they even say that in the problem, X is Diego, Lynn is it's a little bit less. Okay. Any questions or thoughts on that?
No.
Okay. So this is actually what we're doing as a test taking strategy. You're going to take some standardized tests in your life. It's good to sometimes try numbers. So Lynn ran X miles. Okay. Diego ran 3/4 more than that, 3/4 more than that. So we have to figure out, well, what's a number that is again divisible by 4? Right? Because when
Uh,
when you're when you're dealing with fractions, you always want to be able to get a whole number. And I think I heard you say 4. So um, let's just say Lynn ran 4 miles. What is 3/4 times 4?
12 over 4.
Okay, what does that reduce to?
3.
Okay, good. Now it says that Diego ran more than. Does that mean that Diego ran 3 miles, or does that mean something else?
Um, like just more than that. I don't know.
Okay, so did Diego run more or less than 4 miles? Let's start with that.
More.
More. In fact, Diego ran all of Lynn's miles plus the three, which is 7. Is that clear?
Yeah.
Okay, now let's just do another situation. Let's say Lynn ran 12 miles, which is a lot of running, but some people do run that much, believe it or not. I mean, you can always say like in a week or something do to make it more reasonable. 12 times 3/4. Now notice you can multiply in either order. Can you tell me what that becomes?
36/4.
Okay, and what does that reduce to?
Sorry, 9.
Okay, so that means Diego in this scenario ran 12 plus 9, which is 21. And then maybe it's not as obvious here because the numbers don't work out as nicely, but is the ratio 4/7 or the 4/7 the same as 12 over 21? And they actually are. These actually do become the same. Okay, and if you're wondering how, you just divide 12 and 21 by 3. 12 divided by 3 is 4. 21 divided by 3 is 7, like that. Okay, so it doesn't matter what number you pick, you get the same ratio. Now, maybe the harder part is to go to the pictures again. Because we've already done number one, we know that it's either A or C. Does A or C match up with the reduced fractions here, 4 and 7?
Mm, A.
It is A, yeah. I don't really like the way A is, it's exact. I don't really love, this representation is okay. I'd kind of like to see one more little block here, but because then it's kind of like we think of like whole numbers and stuff, but that is
Right.
correct. So um, 3 is C. I'll leave you to think about that in a on your own. We'll move on to number 2. Um, we're actually gonna look at the answers first, which may seem odd, but we're going to look at the answers. This is a test taking strategy where you actually first look at the answers, then you go back and work through the problem. So tell me what you see here, kind of going through. Tell me what you see in letter A. What math operation do you see here?
Like adding,
Adding, right? And letter B is the same numbers, but now it's slightly
multiplying.
different. You're multiplying, so that's different, right?
Right.
Letter C is adding and multiplying. D has some parentheses. E has a different number altogether. I don't know. Is that a multiply?
Yeah, it's multiplying.
Okay. And then what about F? Is that F and E and
Uh,
F look the same?
yeah, multiply.
They're both multiply?
Yeah.
That's really odd that they would both be, and they're the same number here?
Yeah. Oh wait,
Oh,
no.
okay. I'm looking at the
Uh,
pictures and whoever took them, they try to keep them the original size because these are the compressed versions and they don't scale well when I zoom in. Um,
F
but
is 5/4.
okay, there we go. Oh yeah, I can barely see that now. Fives and threes don't look very similar. Look very similar when they're kind of green like this. Okay, so we know we're adding, multiplying, add, multiply. We've got something in here. Um, now, in the case of parentheses, have you guys talked about the distributive property?
Like a little bit, but not really.
Okay, so what that distributive property means, I'm going to write it out here, is you actually take this 12 and you multiply it into both. Okay, so it's 12 times 1 plus 12 times 1/4, like Is that something, does that look more familiar or is that still kind of way?
Yeah,
Okay. And 12 times 1 is 12 plus 12 times a fourth. Can you tell me what that is when it's fully reduced, please?
3.
It's 3, which ends up being 15. Um, so that's kind of odd. Like so D is really like 15. Okay. Um, the ones where you're multiplying are probably the easiest ones to sort of think about, but let's take a look at C next. 12 plus 1/4 times 12. Which one do you do first? Do you add or do you multiply first when you're simplifying?
Multiply.
Right. So this ends up being actually the same as this one here. It ends up being 15 also. All right. Could you simplify E and F for me, please? I'm gonna just step away for 30 seconds. I'll be right back with you. All right, I am back. Do you have an answer for E or F?
Would E be 9?
Okay, good.
And then would F be 15?
Okay. Now, you may be wondering, why are we even doing this? Like, shouldn't we do the problem? It's like, yeah, we should. We will. But the the this assignment is actually more of a standardized test prep thing. It says here on the right, select all that apply. Okay. And what that means is there's typically more than one correct answer, which is frustrating, right? Because they don't tell you how many, you just know that maybe you're supposed to pick more than one. Now, as a test taking strategy thing, you see how C, D, and F are all the same result?
Mm.
It's probably C, D, and F without us like doing any work. Like that's just a side point. That's probably the answer. But um we don't know for sure, but because it's more than those. Um we didn't do B. B is 12 times a fourth, that's 3. Um, and then A is just a random fraction, 12 and a fourth. Okay. So it's probably C, D, and E, but let's take a look at the scenario. Elena walked 12 miles. Then she walked 1/4 that distance. So she went 12 miles plus, well, 1/4 that distance. So this is multiplication, 1/4 times 12. All right. So and we did a bunch of these just now where when you simplify this, this is 3, 12 plus 3 is 15. That is the answer. Now, what they're trying to do in the answer space here is kind of be deceptive. They don't want you to see that, for example, maybe you don't recognize that C, D, and F are all 12. are all 15. Like you have to simplify them first. All right. So any questions on that or thoughts?
No.
Okay. Let's go to 4. 4 is much like the one we just did, and then we'll come back to 3. All right, select all ratios that are equivalent to 4 to 5. Okay, and what you're really doing is you're either trying to get the first number back to 4, and you do this by either multiplying or dividing, or you're trying to get the second number back to 5 by again multiplying or dividing. So like when you look at A, you actually can go to either one. You'd be like, all right, how do I get 2? How do I take this 2 on the left and turn it into 4? Well, if you multiply by 2, right?
Mm.
So if you multiply both numbers by 2, maybe just put that here, you get 4:5. And that one's good. Looks like you might have even already circled that one. Do you write fairly light on your pages?
Yeah.
Yeah, just very barely perceptible there. Um, Now B to get the first number back to 4, you multiply by 2 again. All right, and so that becomes 4 to 6. That's not correct. C is a little bit more difficult, right? It's like, how do you go from 3 to 4? Well, you could add 1, but I said here, well, it's either multiplication or division. You can't add or subtract. So that's out. So you look at the second number. It's like, all right, can you get 3.75 to 5? You can. It's just a little wonky. Okay. Um, so I don't know how much we should go into this one. This one probably is not correct. Now we could do it. We could um, but it requires you to get way more comfortable with fractions. So let's that's kind of the initial analysis. Let's actually see how to do this correctly. So do you remember to convert this to a fraction?
No.
So this becomes 3 plus 0.75. 0.75 is one that you're supposed to be like, oh yeah, that's 3/4. Now, do you remember how to add fractions with unlike denominators?
No.
Okay. You have to start by making a common denominator. So the common denominator is usually just the product here. So it's like 4 and 4. And to go on the right, you already have the bottom. That's fine. You go from 1 to 4, you're multiplying by 4. So you're going to multiply this 3 by 4 and get 12. Now you add the tops, but keep the bottom. Okay. So why are we doing this? Well, our goal, we're either trying to get the first number to 4 or the second number to 5. So I just chose arbitrarily to do the second number to get 15/4 to equal 5. Okay. We have to, and let's consider this to be an X. We're kind of doing this last week. You have to multiply by the reciprocal. Okay. And so what that does on the left is these all cancel. On the right, now you're multiplying. So you multiply the tops, multiply the bottoms. When you reduce this, you can divide them both by 5. And so you get 4/3. Okay. That's like, why are you doing all this? Because that's what you multiply 15/4 by. 15/4 times 4/3 gets you to 5. Now the question is, does that also work for 3? Is 3 times 4/3 equal to 4? Yes, it is. Okay. You'll probably see this again in class. Probably a lot of students will say they didn't mark C right. I can't tell if you did or not. If you're allowed to use a calculator, you could maybe get away with doing it slightly differently, but um, let's let's uh, let's keep going here for number D or letter D, E, and F.
Okay.
Okay, so for letter D, again, our goal is to get it to 4 to 5. This time we should focus on the second one. We should divide by 2 because 8 goes really, I'm sorry, we take that back. We've got kind of the same problem as the last one where we can't get to 4. We can't just divide by 2 because that's the second one. We have a real problem there. So this one again kind of requires you to play this game with fractions. It's like, okay, 8 times what gets you to 5? Well, you end up multiplying by the reciprocal. So the x here is 5 over 8, and then you have to take 7 and multiply by 5 over 8, and maybe that gets you to 4, but it does not in this case. So D is out. And it is probably unclear, but I don't mean I didn't pick the problem here. They're very challenging. So, but E though, E is a little better. If you divide by 2, you get 4 to 5. And that's the one of the ones looks like you chose. Okay, and now we're up to F. There's kind of a reasonableness check here. 27.5, it's about 28. 14 to 28, that's about a half. 4 to 5 is way more than a half. So for sure, this one is also out for kind of that similar reason. Any questions, thoughts on that?
Nope.
Okay. All right, so look at number 3 next here. Could you just confirm, is that 3 over 4, 1 over 4 there on the right?
1/4, yeah.
Okay. So we've actually done a couple of these. This is write a story that can be represented by the equation x plus 1 over 4th times x. We've actually done this a bunch. It's where you do something, your pick. I don't remember what kind of activities you like to do outside of school clubs or sports or whatever, but then you're doing a fourth more. So you're gonna watch the 49ers play today. So let's say on their first drive, they go 60 yards and they score a touchdown, and everyone's very happy. Now on their next drive, they go a fourth more than 60 yards. Okay, so we need to figure out what is a fourth more than 60 yards. We have to figure out 1/4 times 60, which is 60 over 4, which is 15. But that's just the fourth part. The fourth more means you're doing what with this number here? How does this number get included when it's a fourth more?
Um,
We did this in number 1, question 2. We did this in number 2. Is the new number bigger or smaller than 60?
bigger.
Bigger. So one of the ways to get bigger is to add 60 plus 15 is 75 yards. So on their second drive, they went 75 yards. Maybe they got a touchdown again. Okay. My feeling is that